Welcome to our Unit 3 lesson. This is our very first lesson on graphing and writing inequalities. So the learning targets for this lesson are for you to be able to identify the solutions of linear inequalities in one variable, and also to be able to write and graph linear inequalities in one variable. So we need to define what an inequality is before we get started with this. And you are used to dealing with equations. We've been doing a lot with solving equations. And so we're going to switch gears now and start solving inequalities. And an inequality is just a mathematical statement comparing two different quantities or two different things, two quantities. And so when we compare those two quantities, usually one will be bigger or smaller than the other one. So anything where we have a mathematical statement that compares two quantities. Some examples of inequalities I have listed here in the bottom of the slide. And so we're going to talk about what each of those symbols mean. So linear inequalities have different symbols. We have 4 different symbols that we use for linear inequalities. And the first one is the less than symbol. So it has a pointed side that points to the left. And you can remember that one because it kind of looks like the letter L, only it's tilted, and its read is less than. So this statement right here is read, x is less than y. The next inequality is greater than. And so this statement is read, x is greater than y. And that one has the open side comes first, it faces toward the left, and the arrow points to the right, and that is read as greater than. The next one in green here is read is less than or equal to. So the less than part of it is just like the red one where it says less than, but we also have part of an equal sign, which means it could also be equal to. So it says x is less than or equal to y. And then you might guess the next one in purple here is greater than or equal to. X is greater than or equal to y. So the purple one is similar to the blue one, only it has part of an equal sign with it. And the very last one is not equal to. It's an equal sign with a line through it. So it says x is not equal to y. Those are the 5 different inequalities that exist, the different symbols, and those are the ones we're going to be working with in this lesson. So let's see how this works. A solution to a linear inequality is any value that makes the inequality true. Okay, so the solution or the solutions, plural, are just values that make the inequality true. And inequalities will have more than one solution. And so to represent those solutions, to show all the solutions, we use a number line. And so let's go ahead and take a look at what that's going to look like. So here's an example. It says determine which of the values 0, 2, 4, 6, or 8 are part of the solution set of the inequality x minus 4 is greater than 2. When you're given specific values, you just plug those values in one at a time for the variable. So if we plug in 0, we get 0 minus 4, which is negative 4, and negative 4 is not greater than 2. When we plug in 2 for x right here, we get 2 minus 4, which is negative 2, and negative 2 is still not greater than 2. So that is false. That is not part of the solution. When we plug in 4, we get 0. 0 is not greater than 2. When we plug in 6, we get 2, and 2 is not greater than 2. When we plug in 8, we get 4, and 4 is greater than 2. So the only solution we have is 8. Okay, that's the only one that is a solution if those were the only values we had to plug in. Well, graphing the solutions to inequalities, we're going to use an open circle when the equal to part is not in the inequality. So if it's a less than or a greater than, then it's going to be an open circle. So let me go ahead and write that in here. So anytime you have just a greater than or a less than. That's going to be an open circle. If we have a closed circle, that means that the equal to part is part of that and the endpoint is a solution. That's when we'll use a closed circle. We shade to the right for the greater than symbol, and we shade to the left for a less than symbol. And you might recall that the greater than symbol, remember the greater than symbol looks like this, and it kind of points you to the right. It tells you which way to shade. A less than symbol points to the left, and so that tells you which side to shade with the less than symbol. So here we go. Let's go ahead and do some practice. So the first one says graph each inequality. So letter A says W is any number that is less than 7.9. So remember, we have to read this from left to right, and it says W is less than 7.9. We don't have an equal to, so that's an open dot. So I'm going to go ahead and put an open dot on 7.9. And we want to shade to the left. So we want our arrow to go to the left. So if we were to graph the solution set, it would look like that. Letter B, P is greater than or equal to 3. Well, this time we have the equal to with the inequality, greater than or equal to. That tells me it's a solid dot on 3. So we're going to have a solid dot on our endpoint. And our arrow is going to point to the right. So we're going to use the arrow that points to the right, and our solution set would look like that on a number line. All the numbers that are greater than 3 are solutions. The third one, letter C, y is less than or equal to -8. Again, we have the equal to with it. So I'm going to take a solid dot and put that on -8 on my number line. And it's going to point to the left. It's less than or equal to -8. So I'm going to grab the arrow or the line that's pointing to the left. Letter D says 4 is greater than t. Now this one's a little bit tricky. In order to graph these correctly, we always want to have our letter on the left. So you'll notice the open side is toward the number and the pointed side of the inequality is toward the letter. So if we were to rewrite that, we could say t is less than 4, right? Because the pointed side is toward the letter and the open side is toward the 4. So these are the same statement. So now it's a little more obvious. On 4, we're going to have an open dot. There's no inequality, or excuse me, there's no equal to sign. So it's an open dot, and we want it to point to the left. Now, if you didn't put your variable on the left-hand side, you might be tempted to think that that's going to go to the right. So be very careful with that. This time we're going to move backwards. We're going to go ahead and write the inequality based on the graph. So for letter A, our endpoint is between -6 and -8. So that looks like it's -7. And I'm going to use the variable x for each of these. It's pointing to the left, and it's an open dot. So x is less than -7. All the values less than -7 are solutions. For letter B, our endpoint is 15, so that's the number that goes on the right. And I'm going to use the variable x again. This time it has a solid dot, so it's less than or equal to 15. Letter C, I'm going to use the variable x again. Now this one's a little trickier. We have to figure out what value our endpoint is. We know it's going to be greater than, and I just need to figure out what that endpoint is. It's an open dot, so it's greater than. And so we have 1, 2, 3 divisions in between each number. So these are divided by thirds. So there's 1/3, 2/3, and then 1 is the same as 3/3, right? So that is x is greater than 2/3. And letter D, we're going to say x is greater than or equal to, because it's a solid dot, and it looks like that number on our number line is 201. Number 4 says the temperature on a winter day is no more than 40 degrees Fahrenheit. Our problem says to write an inequality showing the possible temperatures on the winter day. Well, it's no more than, so that's the phrase that we need to be able to translate. No more than means it has to be less than, okay? If it's no more than, then it's less than or equal to. It could equal 40 degrees. 40 would still be no more than. So the way we're going to write that then is we're going to write this. Let's say our temperature, okay, on the winter day, I'll just call it T. The temperature is less than or equal to 40 degrees Fahrenheit. Okay? And if you don't want to put your units in there, if you just want the inequality, it would be T is less than or equal to 40. Might be a little confusing to put those letters in for our units. Then it says to graph the solution set. Well, 40 is the number that we want on our number line, so I need to put the number 40 in here. And we want all the values that are less than or equal to 40, so that means it's a solid dot. And the ones that are less than go to the left, so we're going to have all the stuff to the left of 40 degrees. So the temperature is no more than 40. It can go up to 40, it can end at 40, it includes 40, but no more than that. That will do it for this first lesson. We'll see you in class.